So we were talking about this UV rays. No? So we use it for tanning, we use it for sterilization. No? So there are some scanners that are quite cheaper, and they use UV radiation there to remove some bacteria. No? So it is used as a sterilization equipment. No? Now, maybe not too much of this also may probably cause some levels of cancer. No? So you have to protect yourself by some sunblock. No? So you have to put some lotion whenever you go into swimming in the ocean. Next is it is good for producing vitamin D. No? And vitamin D is good for our teeth and bones. No? So although too much exposure is also may be harmful because it will create cancer, but to some extent it may also produce some vitamin D. No? Now, X-ray, on the other hand, may be used for imaging. No? So thermography, or tomography, I mean. No? Tomography is creating an image. No? So it's very helpful in medicine, to be able to see our internal organs without opening us up. No? So to some extent, I think it is also treating some kind of cancer, but too much exposure also can cause cancer. No? So there are people that are actually have to wear some kind of a suit to protect them from X-rays. No? Especially those that are working in the X-ray lab. No? So those that are seen in this diagram are the ones that are absorbing the X-ray. No? So our bones and teeth absorbs X-ray. No? Now here's the suit that probably protects our crucial or vital organs of our body. No? So we wear it. This professional wears it to protect his heart and other vital organs. No? So this is made of lead. No? Ang tingga na bala. No? So lead vests protects doctors and other practitioners from too much exposure to X-rays. No? So lead cannot be penetrated by X-ray. No? Now, engineers also to check the integrity of a structure like a beam of metal or concrete. No? So you can know whether there's a crack inside it by also doing some X-ray. No? So X-ray is not only used for human beings. No? So you can also scan some welded, very thick metals. No? Because inside the welded part of a metal, you cannot really know if the welding was done carefully. No? So some X-rays are also used to check the integrity of concrete, to know the insides of the concrete. So gamma rays are the dangerous ones. So this is part of your electromagnetic radiation, and this has the highest, the one with the highest energy. So it is also used in medicine. So this guy, I think the actor here is Lou Ferrigno. This is an old actor. So they thought of the hawk to be na-radiate siya sang gamma rays. No? So that's why he transforms like this. But he's a fictional character though. No? So I just included him here. No? And the nuclear explosion could also emit a lot of gamma rays that are so powerful and a very high energy. That's why it's dangerous also to be exposed to nuclear weapons. So again, our speed of light in terms of meters per second or in kilometers per second. So how fast does it travel? It can go around the Earth in several rotations in a matter of a very few period of time. So here's the spectrum once again. Now again, the spectrum is so broad, but somewhere in the middle you can see the red to the violet color or purple. No? And we can think of this as 7 colors, but in reality, there are a lot more colors inside. No? So the one with the longest is red, and this is its wavelength, no, in nanometers, no, and the shortest one is 400 nanometers, and we think of the purple or violet to be of that range, no. Now this is how we see things, no. So the reflected color there is the one that reaches our eye. That's why we see, no, that specific color, no. So the seven colors will probably not be absorbed by the material, but that color that is similar to the object will now bounce back. No? So this is the principle of reflection, and we can probably notice things, no, because of its reflected light. No? So everything is reflecting light. No? So they are always a source of light. No? That's why we see things. No? So our eye can detect it, no, because of the beam light, no, from the given object. No? Now, some objects are transparent also, no, that those that permit, no, the passage of light without any obstacle at all. Those that cannot, no, be penetrated by light, we call them OpEC. No? And those that light kind of uh, bends, no? So they are translucent. No? They are partially, no, they are not really that clear. No? So light will kind of, no, move in a different direction. No? So especially if the surface is rugged. No? Now we have varied ways of reflecting light. We have specular and we have diffuse, no, reflection. No? So these are different ways of reflecting light. Here are our different materials, no, that allows the passage or the no, not to let light go through them. No? Okay, so some smooth surfaces will have a regular way of reflecting. No? So if the surface is even and flat, no, so the reflection is also kind of regular. But when the surface is rough, no, then the reflection will be moving at varied, no, varied directions. No, so rough surfaces. No, so usually, no, for surfaces that are kind of rough, you may have there the diffuse kind of reflection. And for mirrors, no, you may probably see, no, a specular kind of reflection. You can see, no, clearly, no, the object in front of you. No? Or like in a surface of water, no, you can see clearly, no, the image of a plant, no, or a tree or a mountain in water, no, because you what you're seeing there is called as a specular, no, reflection. Now it's almost 8 o'clock, and I want you to shift back to Zoom. So, do you hear me, guys?
Yes, sir.